For millennia, humans have stared at the night sky, imagining distant worlds and cosmic wonders. But what if everything we thought we knew about the universe is wrong? The James Webb Space Telescope, humanity's most advanced eye in the cosmos, is revealing galaxies older than expected, planets too massive for their stars, perfectly symmetrical structures, and signals that defy explanation. These discoveries aren't just surprising, they challenge the very foundation of modern astrophysics. Could the universe be far more ordered, deliberate, or mysterious than we've ever imagined? What James Webb has uncovered might force us to rethink the origin of galaxies, the nature of matter, and even our place in the cosmos, opening a door to a reality stranger than science fiction. The first revelations from the James Webb Space Telescope immediately upended expectations. While peering into deep space, Webb captured galaxies that shouldn't exist yet. Immense, mature, and fully formed just 180 million years after the Big Bang. According to standard models, the universe at that stage should have been a chaotic soup of gas, with barely any structure, yet these galaxies rivaled the Milky Way in size and organization. Spiral arms, dense cores, and intense starlight appeared where none should have existed, forcing scientists to reconsider the timeline of cosmic evolution. But the anomalies didn't stop there. In galaxy clusters like Abel 2074, Webb revealed perfectly aligned points of light forming geometric patterns across billions of light years, a level of order that seemed impossible in a supposedly random universe. Even individual stars in these early galaxies behaved in ways that defied existing models, showing motion and energy distribution inconsistent with our understanding of gravity and stellar formation. Each new observation added pressure on cosmologists, hinting that the universe may follow rules far stranger and more precise than anyone imagined, as if underlying patterns or hidden laws were orchestrating the cosmos in ways we've only begun to glimpse. Among the most bewildering discoveries was the massive exoplanet HIP 6e6b, a world that shouldn't exist according to any known theory of planetary formation. Orbiting a star barely 15 million years old, this planet is 7 times the mass of Jupiter and circles its star at a distance 3 times that of Neptune. There's no visible protoplanetary disk, no leftover material, and no gravitational explanation for how such a massive object could form so quickly and remain stable. Some researchers have begun speculating that HIP 6e6b may not have originated in its current system at all, suggesting it could be a remnant from a previous star system, transplanted or reused in ways we don't yet understand. The implications are staggering. If planets can form or appear outside conventional timelines, our entire understanding of planetary evolution may need a rewrite. And as astronomers continue to study HIP 6e6b and other anomalies, the line between coincidence and cosmic design starts to blur, hinting that the universe may be far more complex and far stranger than our models can account for. One of the most visually striking findings from the James Webb Space Telescope came in the form of a near-perfect Einstein ring, a gravitational lens created when the light from a distant galaxy is bent around a massive foreground galaxy. Around galaxy J419, this ring forms a flawless circle, so mathematically precise that even seasoned astrophysicists were left stunned. For such alignment to occur, the galaxies must be positioned with extraordinary accuracy across billions of light years, a scenario so improbable that it challenges our understanding of cosmic randomness. While gravitational lensing is a known phenomenon, the perfection of this ring hints at a deeper symmetry in space-time itself, suggesting that the universe may not be as chaotic as we assumed, but instead governed by an underlying order we have yet to perceive. This discovery forces scientists to reconsider the role of chance in cosmic structures and opens the door to questions about whether hidden laws or patterns dictate the arrangement of galaxies on a grand scale. Perhaps the most astonishing revelation from the James Webb Space Telescope is the discovery of massive, fully formed galaxies existing just 180 million years after the supposed Big Bang. According to our current models, galaxies shouldn't have had enough time to grow to such sizes, develop spiral structures, or reach the brightness levels observed. Yet, these galaxies are as large and stable as the Milky Way, defying the timeline of cosmic evolution and leaving cosmologists scrambling for explanations. If these findings hold, they challenge the very foundation of the Big Bang theory and suggest that the universe may have a history far older and more complex than previously imagined. These anomalies hint at a cosmos that developed with extraordinary speed and sophistication, forcing scientists to reconsider assumptions about the earliest epochs of cosmic formation and leaving open the tantalizing possibility that the universe had a prehistory long before what we have traditionally recognized as its beginning. In a seemingly empty region of space, far from any major galaxy, the James Webb Space Telescope detected an astonishing gravitational lens effect where no visible matter exists. No stars, no galaxies, no black holes. Yet, light from more distant galaxies bends, curves, and distorts, as if an unseen mass is lurking there. Traditionally, astronomers would attribute this to dark matter, the invisible substance thought to exert gravitational influence across the cosmos. But the precision and intensity of this lensing challenge that explanation. The distortion is too localized, too structured, behaving more like a defined object than a diffuse cloud. Some researchers have started entertaining radical ideas that this might not be dark matter at all, but evidence of something ancient, deliberately structured, and still influencing space in silence. This observation raises the possibility of a hidden order within the universe, something deliberate, a structure or entity that has persisted unseen, quietly shaping the cosmos across billions of years. Among the telescope's most striking discoveries is a massive intergalactic filament, a stretch of galaxies and matter aligned with uncanny precision, extending over 1 billion light-years. While cosmic filaments are not new, this one stands out for its symmetry, density, and repeating voids, resembling a colossal grid laid across the universe. Mainstream cosmology attributes such patterns to gravitational forces acting over billions of years. Yet the regularity here is difficult to dismiss. Galaxies follow parallel paths, dark matter clumps at precise intervals, and redshift measurements reveal a wave-like regularity, as if the very fabric of this region was intentionally designed. Some scientists urge caution, suggesting our brains may be detecting patterns where none exist, but others propose a more profound possibility. The universe may hold traces of intelligence, evidence of a hidden blueprint or guiding principle, shaping the cosmos on a staggering scale, leaving behind fingerprints that are only now becoming visible. Perhaps the most unsettling discovery yet comes from a series of faint, rhythmic light pulses recorded during deep field scans in an otherwise empty region of space. These signals are too regular to be random and too precise to originate from known cosmic objects like pulsars or quasars. Initially dismissed as potential errors or interference, independent verification confirmed their consistency, revealing a pattern with no obvious source, no stars, no nebulae, no heat signature, just a perfectly timed flash repeating and vanishing. Scientists are now quietly asking questions that border on the philosophical. Could this be a message not meant to be understood, but simply noticed? If intentional, who or what was the intended observer? These pulses hint at a cosmos that may be far more deliberate and interconnected than previously imagined, suggesting that hidden systems or intelligence could be at work, quietly shaping and communicating through the vast emptiness of space. The James Webb Space Telescope has unveiled a universe far stranger and more intricate than we ever imagined. presenting discoveries that challenge the very foundations of modern cosmology. From massive, mature galaxies forming impossibly early, to planets defying conventional formation theories, to perfectly symmetrical gravitational lenses, and mysterious rhythmic light pulses in empty space, each finding forces us to reconsider our understanding of reality. Dark matter may not be inert, but could carry the echoes of cosmic history, and the patterns observed suggest a level of order and precision previously unrecognized. These revelations raise profound questions. Is there intelligence embedded in the fabric of the cosmos, a hidden memory within dark matter, or signals deliberately placed for us to find? While answers remain elusive, the telescope has opened a doorway into a new era of exploration, pushing humanity to look beyond the veil and confront the possibility that the universe is not only vast and ancient, but also purposeful, deliberate, and connected in ways we are only beginning to grasp. The discoveries of James Webb remind us that we are not mere observers. We are part of a cosmos that may be far older, more structured, and more mysterious than we ever imagined. And